Sound can be described through various ways. There are various possibilities. How can we describe sound? Okay. Most of the time we are describing sound in terms of articulation, but we can also describe sound in terms of hearing, like how do we hear a specific sound. So when we are concerned with the description of sound from hearing point of view, we need to describe various properties of sound acoustically, right? Linguists and speech scientists or speech engineers or even speech pathologists, they are concerned with sound waves most of the time in order to describe sound in terms of hearing. Okay, there may be some possibilities that why do they are working or in describing sound like from a hearing point of view. They may be looking at the differences that how sounds are confused, like how two sounds are confusing, right? So, and there are many other possibilities that why do we go for the description of sound. And the sound wave, the description of sound through wave is a very good way to describe it fully and with in-depth analysis. All right, sound waves. You know, hearing depends on acoustic structure. Acoustic structure, like the physical properties of sound. When those physical properties, when they are heard by a human ear, then the ear can feel the differences, the acoustic differences. So in order to just describe the acoustic structure, we will have to describe a sound in terms of hearing. And this is important to understand and describe a sound acoustically. And then the objective may be to just describe the process of synthesization or recognition of a human speech sound. So for that purpose, we can also use sound waves. And then we can further analyze sound wave, like for recording data and then exploiting it again and again for various purposes. So sound wave is an important entity, and we can describe sound wave for a number of reasons in the phonetic studies. All right. Sound basically differs in three ways, right? Like the pitch or frequency is different, which like number of repetitions are different, right? The periodic repetition frequency. So that may be different of a sound, or the loudness may be different. The loudness, like for example, the displacement of various particles from the center. Okay, so from the center, from the source, how are the particles dispersed from the center point? Okay, so that is called amplitude, basically in technical words, amplitude. So we need to go through the loudness also in order to describe a sound. And then the third thing which is required is the quality of a sound. Okay, so by quality I mean like how is the quality of a specific sound, like in two words of English, bad and bad. Okay, so bad and bad, b and d sounds are similar, but the central vowel is different, and that's the quality, the quality of the vowel. Both vowels are different in quality, right? So these three things are important to describe in order to describe a sound. There might be a possibility that two sounds are similar in terms of pitch, frequency, or loudness, but the quality is different. Or it may also be the case that the loudness and the quality is similar, but the pitch and the frequency is different. So in order to describe a sound fully, we need to go through the acoustic properties of that sound. And for that purpose, we need to look at all these three things, right? So in order to look at all these three things, we need to draw the sine wave, the waveform of a sound, all right? The waveform of a sound. So let me just show you the waveform of a word spoken by our author of the textbook, Leda Foged. This is given in the book. I've taken it from his book, the word father. So he has taken the waveform of the word father, which is given in his book also. You see, this is the waveform of the word, right? And this vertical axis shows the amplitude, okay, the loudness of the sounds, right? And this horizontal view, it is about the length of the sound, okay? And this shows that the length is 0.6 second, okay? 0.6 second is taken, that's the full length of the word father, okay? Which are 4 sounds basically. This is fur, right? Fur, okay? So you see, the consonant, its shape is different than vowel, all right? And this shows that the loudness is different, okay? So it has disturbed the particles different than the vowel, okay? And then sound, so these are the, the frequency, the waves, which is shown here for the vowel, and then there is the, dental the. So it's again the difference between vowel and consonant here, and then shua. The R may not be, may not be pronounced by the person here, okay, by the speaker, but is there, right? So we have gotten the length of the sounds here, and then also the amplitude, and we can also take, if we just expand it, we can further take the frequency and also the pitch. When it is shown on a spectrograph, then we can also take the pitch and frequency, right? But right now, let me just tell you that this part has been expanded below, right? So this is the part which has been expanded here, and this part of the waveform shows that there are 4 major peaks, okay? 2, 3, 4. 4 major peaks are there, and the time taken for these 4 major peaks is 0.04, all right? So 4 major peaks and 0.04 second, okay? Like one is equal to the 100th part of the second, okay? So this is very simply, this means that the repetition were 100 per second, okay? So this sound wave gives us this much of the detail, which can be further exploited in order to describe and differentiate among various sounds, and this is done with an acoustic with more detail.